Okay, so on this question, what I'm seeing two dependent samples because this person takes the pre-test, scores a 61.5, takes the post-test after some training program, I guess, and they drop down to a 54.1. All right, but then this person improved and this person dropped. This person really improved, dropped. This person really improved, dropped. Looks like I don't know. That person did much better. So what we're trying to say is whatever treatment that they're having, whether it's a prep test or who knows what, that the person changed. So what each of these scores are depending. You would think a person that really knows how to study or somebody that's really smart in the subject, really doing well with it would have, it depends. If they do well in the first test, they'll do well in the second one. And I know some of these aren't, but so we're going to say what we're going to test is see if whatever program or treatment they're getting improved or decreased tests. So we'll have to come up. Looks like for looking at their HO and HA, it's just as different because it's a two-tailed test and HA or in the alternative hypothesis, right? And the other clue for me that I know that this is a matched pair situation, it's the first time I've said that in this video, is see the way it says mu sub d, so the mean difference. So what we're going to do is find the differences. So I'm gonna take these two samples and paste them into a spreadsheet. And then I'm going to find the difference because that's what we're talking about. We don't want to treat these are dependent samples. We do not want to treat these as two. Here, I'm just going to abbreviate diff so that way I don't have to spell difference. So now they said post minus pre, right? Let's go back and make sure. I'm pretty sure that's what you do, but see post test minus pre test. So we're going to make sure we do that subtraction correctly so we get the right sign. So post test minus the pre test. And you can do that all by hand if you want, but the spreadsheet does such a nice job about it. Now, we could calculate the summary statistics for this, but being with one sample, well, I think I'm gonna do this. Go up Rossman chance, do one mean, because that's what we're dealing with. I'm gonna paste in my data, clear my data, paste it in, use the data. I'm gonna do a test of significance. I'm going to say it's not equal to 0. Got to make sure you set the HA to the right, what they're saying. So in this case, we're seeing a test statistic of negative 0.41, pretty small t-score, and the p-value is 0.69. Now, this is the one situation where p-value will be bigger than 0.5 because when you're dealing with a two-tailed test, you got to add up both areas. So that's a huge p-value. We can't reject HO. Doesn't look like it doesn't look like whatever treatment or whatever they did with this for the pre-test post-test had any effect, but they're no different. So let me pause this video just a minute. So then I'm going to look at what Math said is the correct answer for these two questions. And I think, isn't that what Rossman Chance said? Negative 0.4, negative 0.41. Yeah, so and now Math might not like that negative 0.041 because it's rounded, but we've got the right answer. It's just a matter of rounding issue. Okay, so that's how you do it. Now, I'm going to caution you, I'll add this into this video. The mistake that people make with this kind of question is they treat these two samples like they're dependent samples, and what they'll do is they'll use that two sample t-test. So what they'll do is they'll come back here to Rossman Chance or whatever they use, and they'll do two means. So they'll treat it as they're different, and they're not. That'll get you the wrong answer, and I won't give you any points for it because you didn't do the condition check. Okay, the condition check for this one is, yeah, these are dependent samples. I'm going to do the match pairs. Okay, so make sure you run those condition checks. Notice also they tell us you believe the population of different scores is normally distributed. So they tell us that's normally distributed, but we've got a very small sample size, less than 30. So, but because they said the population of different scores is normal, we can safely use that t-test, that one sample t-test. Okay, I'll go ahead and post this.